All right, so let's solve some log and exponential equations. I expect that most of this will be reviewed for you guys from Honors Algebra 2. So when we can find the same base on both sides, or, first thing we need to do is isolate the exponential. The exponential here in this case is 1/4 to the x over 3, so we're going to divide both sides by 32. And so we're going to get 1/4 to the x over 3 equals 2 over 32. And then we're going to see if we can get the same base here. 1/4. Say it again. And this is 1/16 or 1/16 or 1/4 squared. 1/4 squared, right. So x over 3 equals 2, x equals 6. So that's the algebra that you can use here to solve when you don't when you have a possibility of getting the same base. And what's the strategy is if you can get the same base, you get the same base, and you set the exponents equal to each other. Okay? Let's do it one more time. And I obviously made this multiplication symbol very large so you know it's multiplication. And we're not multiplying the 3 and the 4 together. We have to isolate the exponential here. So it's going to be 4 to the x over 2 equals 32. Now, I can't get them base 4, so I can get base 2. So this will be 2 to the second times x over 2 equals 2 to the fifth. And the 2's canceled here, so this is 2 to the x equals 2 to the fifth, which is x equals 5. Easy so far? One more. What happens here when you get 5 to the negative x over 4 equals 5. And so this is in a top secret way, 5 to the first. So I can say negative x over 4 equals 1 negative, let's do it all in one step. X equals negative 4. I imagine you want to test full of these.
Yes.
All right. Another type of problem you might have is a log equal to a number. And the x is embedded in the argument. So in order to free it, we have to do the opposite or the inverse operation of taking a log, which is doing the exponential. So we're going to exponentiate this using the same base as the log. So it's going to raise the left side 2 to the log base 2 of x, and then 2 to the fifth. Okay, this is x.
Oh, sorry.
And then 2 to the fifth is 32. Move right along. Is this one already? There's one I missed on the page. Sorry. I'm going to move it up. Through the magic of technology. Wow, this one looks a little bit complicated. It's still a log equals a number. So we're going to work outside in, and we're going to exponentiate using the outside base, which is 2, and then we're going to raise both sides, 2 to both sides, and these cancel because they're inverse operations, and then we get log base 4 of x equals 2, and then we're going to do one more exponentiation, which is base 4, so then we get x equals 16. Everybody follow that? What if I had 3 in a row?
Do it again.
Do it again. So we don't let these nested ones scare us. Another type of problem is when you have 2 logs on both sides. So what we need to do is get a log equal to a log, so then we can exponentiate both sides. But there can't be anything in front of the log. Yep.
So bring 2/3 minus 64.
Yep, we're going to use the properties of logs and bring the 2/3 up to the 64 here. And so we'll get log base b of x squared plus 7 equals log base b of 64 to the 2/3. What is 64 to the 2/3? You can take the cube root of 64, which is 4, and then you can square it and get 16. And now what's the base here? B. So we can exponentiate both sides. And then we get x squared plus 7 equals 16. X squared equals 9. You guys are quiet. X equals?
3.
Well, let's talk about it. Plus or minus 3.
We can do plus or minus.
Can we? We have to check for extraneous solutions with logs because logs have domain issues. Okay, so plus or minus 3 works here because what are we doing with the x? Squaring it. So we do not have an extraneous solution here, so we're okay. All right, next one. So this is an exponential equation. Right, and I could I take log base 0.98 of both sides? Is that going to help us much?
No.
No. So what we're going to do is take the log of both sides, and there's not a nice fancy word like exponentiate for taking the log of both sides. Unless somebody would like to come up with one? Logarithmic?
Yeah.
I don't know if that, is funny or not, but here we go. We're going to take the natural log of both sides. Could we have taken the LOG of both sides?
Yes.
The answer is yes. So what happens when we do this to this x right here? You can bring it down in the front using the properties of logs. So this will be x, natural log of 0.98 equals the natural log of 1.6. And to get the x all by itself, you just divide by natural log of 0.98. And the calculator folks you are going to give me an answer.
Negative 23.26.
Okay, thanks. And why is it negative? Let's think about it.
It's a small number less than 1. So,
Right, because log functions, if we take the natural log, right, that's going to have negative y values when the number, its argument is between 0 and 1. So this is positive and this one is negative on log. All right. Got to get the exponential by itself. We're going to, not all at once, subtract 7, and we get negative 5, and then divide by negative 3, we get e to the negative x equals 5 over 3. And then we naturally
log it.
log it.
Logarithm.
Logarithmic, yes. And then I can bring this negative x down in front, but what's the natural log of e?
1.
1. So this is negative x. ln e equals the natural log of 5 over 3. And you do not have to show me this if you know it goes to 1. I'm just showing it for those who are not here. All right, and so we get negative x equals the natural log of 5 over 3, which is what kind of number? Positive. That's what we call negative. ln of 5 over 3. This is the exact answer. If we type that in the calculator, we'll get an approximate answer, so maybe that's
negative
negative 0.511. Look at how quickly we're moving right along.
Yeah.
I know. Here, we're gonna get the log on one side by itself.
Got 3.
We could go there. I'm gonna,
Don't go there.
you don't wanna go the other way?
I mean, you don't want to go there, so.
I do, actually. I'd like to go this way with the log. It's a positive on that side, but you okay with that?
Yeah, I mean, I kind of have to be, you're the teacher.
Okay, I'll leave it on this side. We got track 3 for John.
Oh. When you complain, things just kind of go your way.
No.
Why would you go log with the, why did you want to go with the log first?
Because it would be common on the right side, and I would have to divide that negative here.
Okay.
That's the only reason.
Okay.
I don't know why. I'd love to remain positive, John.
Yeah, I'm just, you know me, I'm a very negative
I
person.
know you are not negative. Here we go. So LOG, x plus 2 equals negative 2. You know, this is the same strategy here, right? We're trying to isolate the log so that we can. But
Logarithmic.
no, it's already logarithmic. We want to exponentiate, because where is the x?
There,
In the argument?
yes.
So to get it out of the argument, you have to exponentiate.
The 10.
10, yes. Using 10. So 10 to the, 10 to the. You want it. And then,
I say with a laugh.
okay, so then we're gonna get x plus 2 on this side, and this is 10 to the negative 2, which is,
100.
yeah. Okay, 100, and then we get x equals 100 minus 2, so that's gonna be, what is it
Negative.
exactly?
Negative
102.
1.99.
I will say it again?
Negative 1.99.
Negative 199.
That's what I wanted. The exact, and now the decimal, which is negative.
1.9.
Yeah.
But isn't that exact?
Yeah. It's 100.
Is it?
Like, yeah, this is the solution.
Yeah, absolutely. You know what, I'm a fraction girl.
Really?
I am because you all aren't.
So you have, so is it a desire to be different or just?
No, it's a desire to get you guys comfortable with fractions.
Yeah, I like fractions, just sometimes they don't simplify.
Oh, sometimes you don't, you're right.
And this one's always as simple as they can be.
No, not the repeat.
That's
Okay, and never
true.
terminate. So I'm gonna bring the 2 down maybe, or?
Yes.
So we're gonna get 2 natural log of x equals 4, divided by 2, ln x equals 2. And now we're going to,
X equals b squared. Exponentiate.
exponentiate. Yes, I'm not saying that word, so. And then what happens here is when we exponentiate, e and then f will log our inverse operation, so they undo each other. And so this is x equals b squared.
Miss Connor,
Mhm.
on that one, I did first I exponentiated base E,
Sure.
and then
Okay, let's do it that way. Let's do it that way. Because you can absolutely do that. So if we have natural log of x squared equals 4, this is not wrong. You can do this, and then you get x squared, because these cancel, equal e to the 4th. X equals,
I got plus or minus E squared, and it worked out like when I plugged it in.
so what happened?
We do have another solution.
Yeah. So what do we do? Which method is right? Did we lose a solution over here?
Yes.
So what should we do?
And that's,
Exponentiate first.
Did you mean to do that?
Maybe. Yep. Because if we were to graph the natural log of x squared, what would it look like? Natural log of x squared. And? Everything looks like this. You guys have the calculators, let's see. That's well. You see it? Pardon me? So if you look at the equation, what does it say? Natural log of x squared equals 4. If we were thinking about it graphically, what would happen here? And I'm going to make this not to scale. Let's say I put 4 here. Do you see how this is going to be e squared? I'm sorry. What did we say was e? Yeah. E squared, right? I'm sorry, that's going to be e squared. And this one over here is going to be negative e squared. So yes, you should absolutely exponentiate first. So this one, we lost the solution, but this one is graphically doing this, which is what we wanted to do. Let's do a little bit better with that. Okay? Ooh, I lost my arrow, I have to go with it. Can't leave a long arrow there. Fun, see? Sure. I like that. Multiply both sides by 2 first. So this is, oops, I hope I didn't. Should be 2 to the x plus 2 to the negative x equals 6. Then I'm going to set it equal to 0. The equation, so it's 2 to the x plus 2 to the negative x minus 6 equals 0. Now, when you look at this, it's uncomfortable. What do you like? Besides all of it, specifically. What bothers you the most?
There's 2 here.
Is there one term here that bothers you the most? 2 to the negative x, right? I'm going to challenge you to factor that out. Because it bothers you so much. So what stands in its place when I factor it out? 1. Well, that was easy. So,
Now, yeah, that one was easy.
so 2x minus 4, right? If I factor out a 2, what happens here? 2 times. What did you do to the 4 to get this? Divide it, right? So I'm going to take 2 to the x over 2 to the negative x. You don't have to show this. I'm just showing you what we're doing, right? Minus 6 over 2 to the negative x equals 0. So now I'm going to get 2 to the negative x. What's 2 to the x over 2 to the negative x? 2 to the 2x. Good, I like that. And then I'm going to put things in a nice order here. What happens when I divide 6 by 2 to the negative x?
You did 6 times 2 to the
That's right, you do. So this is negative 6 times 2 to the x.
So,
Plus 1. Yes,
I know the feature of the property. And stuff, but I'm confused on how many
now I'm getting which numbers.
like, let's use the X and then.
When I have a negative exponent in the denominator, that means it's parked in the wrong spot. That means it's really, it has to be in the numerator,
Okay,
right? Because it's saying I don't belong here.
okay.
I belong in the top, right? This one says, I don't belong in the bottom. If I were to bring this up, it would be 2 to the x times 2 to the x, and what do you do with the exponents? You add them. When you're dividing, you'd say x minus a minus x, and then you get x to the 2x,
Okay.
or you 2 to the 2x. Does this look like something? It looks kind of quadratic, doesn't it? Yes or no? Okay, let me ask you this. Is 2 to the x, if you think 2 to the negative x, if you think about its graph, is it ever going to equal 0? So 2 to the negative x equals 0 has no solution. Because if we were to take the log of both sides, oops, can you take the log of 0? The answer is no. This looks, the second factor here looks quadratic. Except I don't have an x anywhere except in the exponent. But what's being squared here in the very first term? Maybe rewrite this as 2 to the x quantity squared minus 6 times 2 to the x plus 1. Almost as if it's u squared minus 6u plus 1. Yes, we could use u substitution here. However, I'm going to challenge you not to use u. Because did we use u substitution when we had sine squared x minus 6 sine x plus 1? No, we didn't, did we? So what's being squared here? 2 to the x. So can we say, what's a here using the quadratic formula? Following now? What's a? 1. B is negative 6. C is 1. Everybody follow that? So we're saying then 2 to the x equals opposite of b, which is 6 plus or minus the square root of b squared, which is 36, minus 4 times 1 times 1. All over 2. 2 to the x equal. Everybody follow my steps here? Around the equal. 3 plus or minus, this is 36 minus 4, which is 32, which is 16 times 2. So this is 4 root 2 over 2. It simplifies to 3 plus or minus 2 root 2. 2 to the x equals. So now we have two equations, don't we? We have 2 to the x equals 3 plus 2. I'm sorry?
Did we just disregard the 2 to the negative?
Didn't we discuss that it has no solution?
Well, we did, but so that you can just gone now.
What do you mean by gone?
No.
What I'm suggesting to you, okay, let's say I had, okay, let's try this. This is my little thought pod here. Let's say I had 3xy equals 0. Will 3 ever be 0?
No.
So it's not going to be any solution of it. So what are we doing with 3? It's just not ever going to be 0. That's okay. But x could be 0 or y could be 0. What I'm saying here is this 2 to the negative x will never be 0. So it's just a factor like 3 here that'll never be 0. You don't like that. Right?
I mean, it makes sense.
All right, then what's the other equation here going to be? 2 to the x equals 3 minus 2 root 2. Now, what are you suspecting about 3 minus 2 root 2? What kind of number do you think that might be? Root 2 is 1.414 times 2. Is that bigger than 3, less than 3? Nothing?
It's 1.17. 3 minus 2.
So it's a positive number, isn't it? So we're okay. So to solve this, what do we have to do?
Exponential.
Sorry, you want it? I've got to free this. How do I free this? Log it. If the argument is inside of a log, you exponentiate. If the argument is in.
Oh, so that, I mean, so I meant like log root, whatever fake up, whatever
Okay.
fake made up word you
Please
use.
log this through.
That's what I meant.
We're gonna put this in a calculator, so, okay. Yes, sure, technically, yes. So I'm gonna bring the x down, and this is the natural log of 3 plus 2 root 2. Taking the natural log of this one. This is gonna be what? X equals the natural log of 3 minus 2 root 2. And somebody on the calculator? I'll get right back. I got 3 here. I'm ready.
Orange minus 2, I got maybe 2.54.
Maybe 2 point, okay,
The other one is 2.5.
2.5. I'm so excited to get to X there, I forgot about the natural log of 2, which is bad. So you want this solution? Okay, could we have solved this another way? Could we have solved it graphically? So what about this problem do you like? The factoring. So we're going to try it again. This one might not be so bad. What are we going to do with this one? Keep it factor? Well, I don't know. This is already a quadratic kind of a situation, isn't it?
You say 2 times EDX.
Let's see if it factors like we'd like to normally factor it. We could say 2 EDX times EDX, right, gives you 2 EDX e to the 2x. Say it again? Minus 1 plus 3. And so now we have two equations. We're going to say equals 0. 2 e to the x minus 1 equals 0, or e to the x plus 3 equals 0. I'm going to work on the equation to the right because I'm in my head thinking graphically. E to the x plus 3. What do you know about the e to the x graph? Right. But is it ever going to be equal to 0, that equation? And this is how we know algebraically. We would say e to the x equals negative 3. We would take the natural log of both sides. Oops. Which will be x natural log of e equals the natural log of negative 3. Wait, can we do that?
No.
No, that does not exist. The domain error, so we can say no solution for this side. And then this side's gonna be 2 e to the x equals 1, e to the x equals 1/2. What are we gonna do naturally? So we get x, natural log of e equals ln of 1/2, and here it said, well, guess what, that's negative ln 2, because you can rewrite this as ln of 1 minus ln of 2 if you expand, and ln of 1 is 0, thank you. And that's equal to negative ln 2, and then this goes to 1, and x equals negative ln 2. All right, I know you probably, I don't know if the back page is blank, is it, the very back?
Very back.
No, it isn't, is it?
It is.
It is.
Okay, look that over, I want to do one more so that you're comfortable.
Come to the back.
Yeah. So I think the rest that you can probably do. I'm gonna make one up here. Because you don't like these, I can tell right away. What's the first step gonna be?
Subtract 8.
Subtract 8. Yeah?
So, don't have like, what we did earlier with 2 to the negative x and all that, why can't we do that with 5 with 2 to the x? That's also not every full 0, that's the difference.
With 2 here?
Yeah, like,
You can, but it's not gonna make quadratic. You can factor that out, yes. But you should always factor out the lowest exponent, which is negative x in this case, okay? Because it's going to make what's left easier to deal with. It's a great question. So what are we factoring out here? 5 to the negative x, which is uncomfortable, I know. What's left here? 5 to the x over 5 to the negative x. Plus 1, right? Minus 8 over 5 to the negative x equals 0. If I were to multiply that back in, do I get what I started with? So what do we do now? This is 5 to the negative x. 5 to the 2x minus 8 times 5 to the x plus 1 equals 0. Is this quadratic in nature now? What's A here? It is 1. B, negative 8. C, 1. So what am I going to say? What's my x here? It's going to be 5 to the x, isn't it? So it's going to be 5 to the x equals 8.
Oh, that's
Plus or minus the square root of 64 minus 4. All over 2. It's going to be 5 to the x equals 4 plus or minus root 60. Uh, 4 goes in there. Right, it goes in there. 20. 2 root 15? And what happens to the 2? They go away. So 5 to the x equals 4 plus root 15. And 5 to the x equals 4 minus root 15. Root 15 is going to be just a little bit less than 4, isn't it? Because root 16 is 4. So I know they're both positive. So I'm going to take the natural log of both sides. So I get x natural log of 5 equals, I took a liberty there. Can you think that? Natural log of 4 plus root 15. X equals natural log of 4 plus root 15 over natural log of 5. This will be x natural log of 5 equals natural log of 4 plus or minus root 15. X equals natural log of 4 minus root 15 all over natural log of 5. So I'm just going to leave these as exact answers. What about 5 to the negative x? 5 to the negative x equals 0. We could do this and try to take the log of both sides. So it would be negative x natural log of 5 equals the ln of 0. Uh-oh. What happens here? That does not exist, does it? So this is no solution. All right, so I did 2 of them. You feel better about those? Yes? Not as scary? How do we solve an exponential? We cross multiply? I know you can do this one, right? This one, we have to consolidate the logs on the left here. So I'm going to raise the 1/2 up. And we're going to get log x minus log of x plus 4 to the 1/2 equals 1. So when you have unconsolidated logs on one side, you must consolidate them first before you exponentiate. So this is subtracting 2 logs, which means division. So this would be log of x divided by the square root of x plus 4 equals 1. And this is log base 10, right? So when I exponentiate, it's going to be 10 to the 10 to the. And then we get these cancel because they're inverse operations. X over the square root of x plus 4 equals 10. How do we solve this? We're going to cross multiply. This is 10 root x plus 4 equals x. I'm probably going to just square it here. You take that? Can you square both sides? What are you inviting?
Please stay in your first block class at the bell. Further announcements will happen in your first block class. Thank you.
100 times x plus 4 equals x squared. So I'm going to move it all to one side. X squared minus 100x minus 400. Is that factor?
No.
No? Maybe x minus 20 and 5?
Good morning, students and faculty. Please stand for morning prayer and pledge of allegiance. If you're in the hallway,